Alright, time for another DraftPhysics.com, debatephysics.com, also video presentation. And my chair's in the wrong fucking place. Oops, excuse my French. Anyway, some language. Anyway, English. Please. Anyway, so I found another channel, underviewed kind of thing, physicists, so frankly you can't be swamped with responses and issues and things to do. So maybe he'll engage in a little bit of conversation on the foundations of physics, the stuff he's teaching. Now these people are teaching this stuff, so they should be willing to defend it because they're teaching it. They're trying to pollute other people's brains with what I would think as nonsense and garbage, and that's cruel and not a nice thing to do. And frankly, they should admit their crimes and just say, whoops, my bad, sorry about that, yes, I had it all wrong. All right, so again, I'll just use this simple example to start with in case he's paying any kind of attention. So I can have two things. I can have a 5 mass train and I can have a 10 mass, okay? And I can have a 5 going 10, I can have a 10 going 5, right? And the simple argument is I can push them away with a force, an explosion. They're going to go away with this having twice the velocity of this. All right. So, and if I tied a string to them, what do you think is going to happen? A non-elastic string. Well, I can't even hold those even. Anyway, so what do you think is going to happen? They're going to reach the end. And the thing with twice as much kinetic energy isn't going to, not be this way. Isn't going to win, is it? It's not going to win, right? They're going to pull off. The two things have the same momentum. They're just going to go bleh, and that's going to be the end of it. So, I mean, it's a decisive experiment. That's what it would do. If physics actually did these experiments, how the outcome's going to be. So, kinetic energy is absolute nonsense, invented by one guy. Huygens first said it in one little sentence, and then another guy, Leibniz, decided to make a show of it. All right, even write the nephews and nieces of the king and try to convince them that Newton and Descartes needed to be put in jail because they were talking heresy. Anyway. And he just proclaimed that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. Physics hasn't even done that experiment. They could drop both things into a joule tank, and measure how hot it makes the water, and find out that, it doesn't make any difference. It's the same momentum, same energy. Rocket ships, do you really think the rocket cares about your kinetic energy formula? If you calculate the kinetic energy of the thrust, which one do you think is going to move the spaceship? The calculation for kinetic energy, that'll be extraordinarily high, 50,000 joules. Momentum says, no, it's only 10,000. 5,000. 1/10 of that. Newtons, whatever you want to call it. Doesn't matter. You can convert either one into either one, so let's not pretend they're not the same thing. It's a quantity. And the fact is what's going to move the ship? Well, the ship's going to get moved by the momentum, the opposite, equal and opposite reaction. The thrust going out and the thing that's going to oppositely move the spaceship is going to be the momentum, not kinetic energy. Kinetic energy fails the lever test. Okay, the levers say, something going 4 times the velocity. A 1 mass going 4 times the velocity equals a 4 mass going 1 velocity. And so I go on and on. It's a failed, stupid, idiotic idea. It should have never been adopted by physics. It's absolute nonsense. Yes, your whole standard model is built out of it. All of your theories are all built out of using the stupid mv squared. But it has no credibility as science. Completely unproven, undemonstrated, unevidenced, made up mush. And there's a ton of evidence saying it's not true. The 5-ton train versus the 10-ton train going half the speed. You're not going to win the argument. If you actually do the experiments, they're going to prove that it doesn't exist. They have crashed cars at 50 miles an hour and 100 miles an hour, and there's absolutely no evidence of 4 times the damage. Just twice the damage, twice the speed, twice the damage. All right, so the whole thing is nonsense. You ought to fix it, okay? Quit pretending you're teaching solid truth when you're teaching mush, okay? So I've said my piece. And now we'll play his video, and I'll just point out all the errors, the misperceptions, the wrong ways of describing. and such. And nothing personal. I just mean it's physics, it's science, it's one of the most important sciences. I mean, it's the elemental science. And if you don't get the elemental science wrong, right, you're going to get all kinds of things wrong. It's really important to get the foundations right. And bent space is nonsense, frankly.
Physics in terms of energy. This is actually the most sophisticated and most modern way in which our theories are done.
So I have sped this up. Maybe I've sped it up too much. Maybe we'll cut him a break. It takes longer, but yes. It's probably a little too fast. So, okay, I'll play fair.
So we're going to talk about potential energy. And all I'm going to say is that if you go into physics and you decide to become a physicist and you work in these areas of theoretical physics, you're going to see more advanced applications and
Yes, convoluted nonsense formulations, all kinds of per second kind of nonsense, okay? Gravity's a time-dependent force. It's like sticking something in a river. It's how long you're in the flow will decide how much of the energy you can extract. You know, it's a paint spray kind of argument. You go through the spray quickly, you're not going to get very much paint on you. Gravity works exactly the same way because thermodynamically gravity's a real force because gravity causes real momentum, causes real pressure, heats planets. The planets have to radiate that heat. That radiation ends up being gravity for another planet. I mean, it obviously has to be a conservative system. Bent space is not conservative. How do you put the heat back into the bent space? I mean, it's nonsense.
concepts built upon this concept of potentials and potential energy.
So again, this concept of potential energy, which is again nonsense. There's no, the things don't have this potential energy. It's always stored in some real form, and it's always still energy. It's still moving. It's still doing its little stuff here. Okay, where energy levels of electrons, all that kind of stuff, is all dictated by force, and the force is still active. It's not sitting in some potential state. It's just trapped. And once you let it free again, okay, then it can go push some other stuff. But while it's pushing something, it can't be doing anything else. So the universe is just energy in the form of this little discrete bits moving the speed of light, and you can collect them, and they'll cause you to move. And while you're collecting them, they're not going to be going the speed of light anymore. That's the obvious point. And so in some sense, you've degraded the energy by slowing it down.
For example, when you look at the equations for the standard model of physics and you see all those funny symbols with an L and everything else, that's a Lagrangian, okay? And that describes the energy of the system, the fundamental fields themselves.
Right, so there's no fields and all this other stuff. There's just a simple concept that energy can either be free, moving through the universe at the speed of light, or it can be attached to electrons and protons and be pushing them in a direction. And that's the only thing that can happen. There's only two forms the energy takes. Matter only has three forms. It can be going that way, it can be standing still, or it can be going that way in the three dimensions. But that's it. There's very uncomplicated.
That make up all.
And it's all momentum. The force has momentum. The discrete photons are not massless nonsense. They carry momentum. You can't carry momentum and have no mass. That's nonsense. I don't know why you teach something that ludicrous. It has no mass and yet it has a momentum. I mean, come on. It breaks your own formulation. It's nonsense.
All of these fundamental particles that we have and all the interactions between them.
Yeah, so all this nonsense, because the only real stuff is electrons and protons. You put an electron next to a proton, you have a neutron. There, you've completed the elemental diagram of matter in the universe. There's nothing else you need to learn about in terms of any particle or object. Those are the only three objects, and there's really only the two objects, the proton and the electron.
These particles. So really, when you understand the basics of how energy works in physics and how we formulate things, essentially, as you go further along and you study, you just get to be more and more advanced and more abstract concepts.
Yeah, exactly. More and more abstract, nonsensical, wooey, fudgy, messy, sloppy, incoherent, nonsensical, more forky symbol stuff. More Einstein equation kind of crap, where the equation has 17 equations built into it.
Built upon that same premise. As a matter of fact, we're going to talk about springs. And
Yeah, he really didn't talk about it much, frankly. I mean, I think I watched almost the whole video, and it wasn't much talk about springs. But clearly, he's not going to get springs right either, in the terms of the fact that they very good at collecting energy, very poor at releasing it.
elastic potential energy. And what's amazing is these springs, they become simple harmonic oscillators. And these simple harmonic oscillators can become quantized. Okay, that's quantum mechanics. You can quantize that system.
All energy does that automatically. There's no such thing as canceling energy. So anytime, like we go into the earth pushes us back. We go into the earth pushes us back. There's always pieces of us going down and pieces of us going up constantly because of the two interactions of the two forces. It's just a fact that the chair I'm sitting on is more than just heated by my body heat. It's heated by the fact that I'm constantly stressing it. I'm constantly pushing into it. There's radiant heat coming off of it because of this constant pressure. And if the pressure isn't realized by the chair seat, then it's realized by the legs of the chair, and then it's realized by the concrete, and then it's realized by the center of the earth. Gravity heats objects.
And then you can make it as a
Therefore, you have to explain how the heat you created with gravity, the momentum created by gravity, an asteroid crashes into the Earth. Okay, some portion of its motion is because of the gravity of the Earth. That motion creates obvious heat, and now you have to explain how that heat isn't free energy, because how do you convert it back into bent space? And the simple answer is, well, the space isn't bent. The fact is we're in a very hot universe, and the fact is that heat is compressing things constantly.
field, certain field.
It's compressing them by absorbing the energy. The matter has to be pushed. The matter moves slower than the force. The energy coming up from the earth is insufficient. I can see the universe. The energy directly hits me. The energy hitting the other side of the earth has to plow through the earth and move a bunch of electrons and protons. As it's moving the electrons and protons, it's heating them, it's being used by them, and it doesn't get below me. So there's less energy coming up from below me than energy coming down from above me at every moment. And the simple truth is that I'm stuck in that differential. Now, obviously, a millisecond from now, the energy that should have gotten and pushed me is going to show up and be radiated, but it's going to show up too late. Simple truth. It's not going to get here when it needed to be here. It's going to get here after I've already sunk into the gravity well.
Fields like the electromagnetic field behave very analogously.
So there's these analogies. It's all one field, and it's just bits of energy, and you can put them at a frequency, dot, 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 and that's recognizable. It's a signal. It's a pattern. And then you can change it with magnetism, and you can be spreading the electron and proton force in differentials. If you said electrons were giving off green and protons were giving off red, you could understand that there'd be a mixture of those forces coming off of these polar atoms. And they're not polar north-south, they're polar north-north, south-south. But anyway, that's why it's perpendicular, the field, by the way. But anyway, the point is we can see patterns, but we don't have a detector that can detect force that doesn't have a pattern. So there's a whole bunch of stuff hitting us. I have phone calls, all kinds of crap going through me right now, banging into me. And there's also stuff that we can't create a detector to detect, and that would be the force of gravity. But it was created by heat originally. All of it's created by what you could call heat, and you can have heat in a straight line or you can have heat dispersed. The fact is, when something's moving, it just means that it has heat in one direction. Simple explanation.
To a big set of simple harmonic oscillators moving and oscillating. And so quantum field theory itself and quantum electrodynamics is a very advanced
It's a bunch of convoluted nonsense that's all circular. You create equations to justify equations to justify equations to justify equations, and so all the equations say the answer is 14, but the question was 2 plus 2, and you don't even have close to the right answer.
Formulation of that basic spring theory. Okay, so I call it spring theory as opposed to string theory. String theory is, of course, a theoretical method.
So springs would be a bad example just because the very fact that they're oscillating after they've released their energy, or after they've pushed something, the very fact that they remain oscillating is a clear indication that they're failing to put the energy into the object that we're supposed to be pushing.
Mathematical hypothesis, or I wouldn't say it's a theory, but it's a hypothesis, and it certainly has some merit, but it's not completely verified. It's not verified at all experimentally, actually. Whereas our quantum electrodynamics is verified.
All right, so this is the nonsense part. That is verified by something. You have one experiment, magnetrons, okay, measuring something. You already know what the answer is, and so you just do it to, more decimal places because you already have a formula dictating what the machine produces. You're not making some real measurement of something real in the universe. You've created a machine that produces an answer that's completely compliant to your equation. So it's you've made a machine that says you look marvelous. Does that mean you look marvelous because you made a machine that says you look marvelous? Come on. I just point out your green screen kind of sucks. You ought to get it to work a little better than that. I mean, you have dark hair. It should be pretty easy to get it working better than that.
Phenomenal.
I mean, it's blinds that have a real, green doesn't work, blue doesn't work,
Experimentally. So anyway, I digress. But the point is that whether you study physics into the future or not, this section is very, very fundamental and very, very.
Energy is everything. Yes, exactly. Like physics should have figured this out a long time ago. Well, Descartes did, okay? So Descartes gave you the answer in the 1600s. He told you this simple thing that it appears that the universe was just thrown and all the energy is in it already. And even though I am a Jesuit and I believe in God and all that kind of crap, obviously God doesn't have any role to play because, it's already doing everything. Everything's already happening. The energy just moves from this object to that object to that object to that. It just moves from place to place. All the action is already in the universe. It's already acting. You don't need to do anything because the acting is just going to be circular. So you already had the answer and you spat on it and marched onto your little, wooey parade. Let's talk absolute nonsense and babble instead. You invented a religion. I call it the pervertiverse, by the way, so it wasn't in the title, but
very important.
Oh, I should be playing this. Sorry. Yeah. Oh, my bad. Yeah, I can't be perfect, right? I'm I'm outstanding in my functionality, but I can't be perfect. Continuing.
So we're going to start by talking about energy and what energy is and how we can start to formulate it mathematically. But first, to do that, we have to.
Yeah, so mathematically. And so the mathematics is just, it's such a basic idea that, yes, let's just take the essence of something and understand the essential part and formalize it. So that part of math is so brilliant, but that's not their math. Okay, their math is rearranging things and perverting things to create the illusion of some sort of coherency. They make the formalization do something the reality is not doing.
Understand what it is, we have to define it and sort of start with the basics and then slowly build it up from there. So let's go ahead and get started. So we've got our lecture for today. So I'm going to go ahead and share this now. Okay. And then, so work and energy. So the centralizing concept of physics is this.
So they have a work equation that justifies the energy equation. So it's completely circular. And it all goes back to gravity and that MGH nonsense, which is just wrong. Okay, it's a time-dependent force. It's 9.8 meters per 1 second, not seconds, and certainly not seconds squared. It's 1 second. 1 second squared is 1. Okay, so the squared is superfluous nonsense. But why is it there? because when they manipulate the formula in just the right way, they can end up putting that square on the velocity. And that's where mv squared gets rationalized by circular mathematics. So they're just finding a way to force the rest of the physics to justify the mv squared when there's no justification for it. That's why they say per second, is because if they don't say it, they can't put the square there and they can't pretend there's something needs squaring.
Concept of energy. And it's something that you hear a lot, but what does it actually mean?
So he shows the rocket, and this is the example. They keep saying the thrust equals the amount of energy going into the rocket. Oh, well, there's no equal and opposite reaction based on kinetic energy. So he has the word kinetic energy in bold looking at this stupid rocket. Now, you tell me as a physicist that you're going to deny the fact that if I calculate the momentum of that thrust, that will tell me what I'm going to get out of that rocket, how much energy, how fast that rocket's going to move, how I'm going to push that mass a velocity. The momentum will give me the right answer. Your kinetic energy theory will not get me the right answer because it doesn't obey Newton's third law. Okay, there's going to be a hell of a lot more kinetic energy coming out of that exhaust than is going to be shown to happen in that rocket's motion. So it's just a canard. It's a frickin' lie is what it is to sit there and imply that kinetic energy is proven by rockets when they prove exactly the opposite. Do you really believe they used the kinetic energy formula to decide how much thrust to use to land the lunar module? Or did they do what that Gravity movie shows, which is they're just saying it's a fire extinguisher. You're going to launch a certain amount of material mass, and you're going to launch it at a certain velocity, and you're just going to get the equal and opposite reaction. It's going to be decided. Momentum's going to decide how fast that rocket goes. Kinetic energy is going to have nothing whatsoever to do with it. It's going to be not visible. It's not going to show any part. It's not going to play any part. So it's just a lie.
We have different types. We have kinetic energy. That's the energy that an object has by virtue of the fact.
So he's never going to say, in this video, I don't think there was any one moment where he said the word momentum. Except as, well, you double the momentum or you square the momentum or something like that. But he never talked about momentum as being energy in the universe. I mean, it's just so wrong.
That it's moving. It's 1/2 mv squared or p squared over 2m, where p is the momentum. You can work that out for yourself because if you define...
So that's the only time he's going to say the word momentum. So working it out for yourself, working out a pile of nonsense, okay? Again, if they calculate the thrust leaving the rocket in kinetic energy, they're not going to see the same motion in kinetic energy of the rocket. The rocket will not be going anywhere near, okay, the same amount of joules of energy. It's not going to be represented in the rocket's motion. There's going to be, just like adding 5 tons to the 5-ton train, all right, having a 10-ton growing 5, and you've lost half the kinetic energy. They've lost hundreds of times the kinetic energy. They're only going to get 0.6% of the kinetic energy into the rocket. And they're going to get all of the momentum into the rocket. So which one sounds like the more valid theory? The one where you get 100% of the momentum into the rocket, that works. The other one, you only get 0.6% of the energy into the rocket. And you're saying that's the right theory.
The momentum to be mv. And then you square it. You're going to have m squared v squared. You divide that by 2m, and that gives you 1/2 mv squared. Non-relativistically, of course. Relativistically, it's a little bit different. But we're only doing non-relativistic physics here. So that works out just fine. Oh.
So relativity only has an importance here is that I could make the analogy of the boat sitting on side of the Mississippi River. Well, the Mississippi River is only going 30 miles an hour. So putting a boat in there, the most I can go is 30 miles an hour. So yeah, I'm going to have a real problem gaining any extra velocity. But if I made the river going the speed of light, which gravity's doing, then obviously relativity is going to be meaningless because I'm not going to go anywhere near fast enough to dilute the force. The force isn't going to have any problem catching up to me. If I'm going 30 miles an hour, the force isn't going to have any problem pushing the crap out of me still, because it's going almost 1 million times faster than I am.
Okay, so There's also potential energy associated with an object's position. Now, this is a very, very important idea here.
Yeah, this is very stupid, okay? Because all this is all, again, you're just saying it's a stream, okay? When they teach relativity, right? This is the big lie, all right? When Leonard Susskind at Stanford teaches relativity theory, what does he use? He uses mock gravity. He uses water, a stream of water, a flow of water at a constant rate, and that pushes things into the convergence, which he calls the anti-divergence, because they don't want to concede it's a convergence. And that's all that's happening. So there's a convergence of straight line force coming into the Earth, and it's coming at all angles, you know. So it's some of it's hitting me at this angle, and that has a component down, so I get pushed down. So everything above 1 degree and 179 degrees has a component pushing me down. And that's what I'm getting pushed by, is a bunch of vectors hitting me, okay, at these angles, giving me a component of energy down, and there's just not the same number of vectors coming from the Earth. And it's a simple equation. I'm falling into a stream. I'm falling with a stream that's going the speed of light, so obviously it's going to have a pretty constant ability to accelerate me. But I don't have the potential. The stream has the potential. Gravity has the potential. Gravity has the capacity to push that thing down. And it's going to push it down in a time-dependent manner. It's going to be 9.8 meters per 1 second of increase in your velocity. It's not going to be any other distance is irrelevant. It's a consequence of the time dependence. 1, 3, 5, 7. This is old Galilean physics, and they can't even be honest to that. They can't even respect the giants they're supposed to be standing on. Instead, they're stomping on the giants, Galileo, Descartes, and Newton, to create this pervertiverse.
It turns out that an object has energy not just by virtue of the fact that it's in motion, but by virtue of its locality, its location.
So again, it doesn't have it. It has to be given to it. Something has to give it energy. It has to have contact with it. It has to hit it with actual rays. Okay, I can be a piece of radioactivity and I hit you with a bunch of invisible rays. Well, they're real rays of real energy. The real stuff moving, and I have to have contact with that moving stuff for it to move me. And those are the rules. There's no magical movement. Everything has to be pushed through contact.
If I'm located at a different point in Earth's gravitational field from the surface, a height above the surface at different points, I have a different energy.
You don't have any different energy because you're just assuming nothing stops it before it hits the ground. You're just assuming, well, this is the total distance it will be allowed to fall, which is going to be a total amount of time. And it's the force happens in clumps of time. You only get 9.8 per 1 second. And yes, in the second you travel 3 times the distance. So what? You didn't get 3 times the energy. You only got 1 unit of energy because you only were in it 1 unit of time. It's paint spray again argument. There's a paint sprayer, okay? And it just matters how much time you spend in the spray will decide how much spray is on you. It doesn't matter whether you move this way or that way or do this or do that. It does not know that shit's going to matter. Well, obviously to some extent if you move close to the sprayer because it's not like gravity. It's not a 4,000 or 10,000 or 100,000 mile sprayer. So it's, but I'm just saying relative changes in motion. If you're just doing a tiny bit of changing in your motion, it's not going to make any difference whether you're going up and down or doing this or doing that. It's going to matter how much time are you being exposed to the spray, and that's all that's going to matter. A meteor comes crashing into the Earth, all right, at 600 miles an hour. It's in the strong gravity for 2 seconds. Well, then it's going to be going 6,019.6 miles an hour. That's all it's going to get from the Earth's gravity. It's not going to get any huge amount of increase in its velocity because it wasn't in the gravity long enough to get any increase in its velocity.
Associated with that from the gravitational potential energy. And we'll talk about this a lot more. I'm just sort of introducing this idea. But just note for now that it turns out that where an object is located determines its energy. And
So it's again, it has nothing to do with the object. The object has no energy until it's given energy. I mean, to say I'm holding a wrench and I'm outside the space station in space, to say that the wrench has the potential to be thrown, well, duh. But I have to throw it. And for something to fall in gravity, the gravity has to hit it, affect it, make it happen. The gravity has the potential to do work, not the object.
this applies to chemistry as well, because when you have molecules and you have electrons and protons, depending upon where the electron is located in proximity to the proton, it has a different energy associated with its locality and its orbital. You might have heard that term orbital. There's different energy levels, and it can only be located in certain.
And they have that exactly backwards. It's the stuff on the inside of the atom, the stuff close to the nucleus that's under high pressure. It's really attracted, really locked. The stuff on the outside is the loosey-goosey stuff that doesn't have any energy, frankly, because there's very little force binding it to the atom.
Certain places because of quantum mechanics, but classical physics already gives us this concept that where it's located also defines a very specific energy that it will have. So that applies to chemistry as well. And actually,
So again, the thing doesn't have the energy. The thing is in a circumstance where it's either in a stream or not in a stream. It's either in a circumstance that has the potential to push it. So the case of electrons and protons gets a little complicated just because they're negating each other's force, and it's the force vacuum that's actually creating the potential for an expansion. It's because you can break the vacuum.
every chemical reaction that you can think of, a chemical reaction like burning something, right? Like burning oil, all you're doing is
I mean, I just suggest if this guy's still listening or he gives a shit about anything called the truth, go to debatephysics.com and there's this video called The Simulation, and go look at that simulation because it perfectly illustrates the function of charge with just 2 plus 2 plus 3 physics.
you're taking those molecules in the oil, let's say, the carbon molecules, and you're rearranging the electrons. You're changing where those things are located, maybe breaking a couple of bonds, moving things around, but you're not actually doing anything to the protons and electrons themselves other than reassembling them. But even doing that releases energy because there's energy by virtue of the electron and proton having various distances away from each other. And that's
Right, but there's the force between them is the components of the energy, and the simple rule is that an electron sitting here, I can push it this way, but I can't push it both ways. Okay, that can't happen. The electron can't go both ways. It can either go one way or the other way, and it always has to be obedient to the force that pushes it. So if 5 things come this way, it has to go 5 pressures of energy that way, or it has to reflect 5 things before it can stop, and then it can go the other way, but it has to stop in between. It doesn't have any freeness. It has to actually collect energy. The energy sticks to it and moves it, and obviously it moves at a much slower speed than the speed the force was going, because obviously the electron weighs more than the element of force.
essentially all of chemistry in terms of its energy. Now, what about nuclear physics? What about when we have the nuclear processes going on? Well, then we're doing the same thing, but we're not messing with the electrons and the protons and where they're.
So I would just describe that as like breaking a magnet. So you put you force, okay, 2 north side magnets together because you fool them, okay, into thinking. Well, no, let me do it this. Let me do it with real magnets. You have a north head of the magnet here, and then you have 2 souths sticking to it, right, on either side. So now you've gotten 2 protons really close to each other. 2 south-facing magnets are really close because there's a north in between them. And I quickly slide the north out. Obviously, the 2 souths are going to fly apart with a lot of energy. So that's the nuclear part, is you start breaking the neutrons, and that creates a huge amount of expansion.
They are located to each other. We're playing around with the protons and neutrons in the nuclei of atoms, and we're dealing with those forces, where the protons and neutrons are located and how many neutrons we have in a nuclei. That gives us a type of potential energy too, a nuclear potential energy. And And so that's nuclear physics. And
Right, so it's just about the arrangement of a bunch of dipoles, the neutrons. And if you pull the electrons out of the nucleus, there's electrons in there, those are the neutrons. If you pull the electrons out, then the protons can see each other. And when the protons can see each other, they're going to run away from each other really fast. That's nuclear. That's an atom being disintegrated.
energy and how we generate energy in nuclear physics. Okay. And then there's other things, other ways to do that too. For example, we can have a particle of matter and antimatter. We can put them together and they can annihilate.
All right, so this whole antimatter nonsense, again, they don't have any images or photos or science of any kind to show you the evidence showing you here's one of these positrons. You know, they have a 1964 photograph, of a positive, a proton going through a piece of lead and popping out the other side. And they decided to call it a positron, right? 3 other guys did the same experiment, and they said, it's just a fast proton. Faster than we thought it would be going after going through lead. We thought it would slow down a lot more, and it didn't. And so they decided to call it a positron because it's going too fast. And that's it. There's no science to this antimatter crap. Oh, it's just all so, it's so bad. I mean, like I say, every time they had a choice to get a right answer, they chose the wrong answer. It's like they got a total 0 on the test. Every single question, they decided to go with woo instead of reason. I gotta let him talk more. But look, every one of these sentences is wrong, so I should point out the sentences that are wrong. They're just wrong.
And then we have photons, which are just essentially a form of like pure energy. Basically, it's carried off by the photons. Okay. And that's another process.
So again, he calls the photon pure energy, and that's the truth. Okay, anything going the speed of light, anything made out of stuff going the speed of light, that is the elemental force, and that's all we collect. We collect it. The Earth is collecting it right now, and by collecting it, by banging into the matter and moving the matter, giving the matter momentum, it's creating a huge amount of heat, and that's why the most of the Earth is melted rock.
That's the most energy releasing process of those 3, right? The least releasing one is burning something, where you're just changing around the motion, where the electrons are located in proximity to the protons, because that just releases a little bit of energy. The nuclear one, where you're moving things around within the nuclei, that releases more energy, but still a small fraction of the total rest energy of the system, giving.
So it's all just releasing, taking the force and letting it go back out, pushing stuff. So you free the force, it's returned to its speed of light, and now it can do work on something else. But it's always working. It's always just going from one house to it's just always working. It never stops working. You never consume energy. You just borrow it. You just slow it down for a little while, and then it goes back to doing its adventuring.
The mass of the particles. And then the annihilation thing, well, that releases all of it. So that's the most.
So there's no annihilation. You can't annihilate electrons and protons. So that's more just made up crap that they say happens, and they got no real evidence that any of that annihilation crap ever happens.
Energetically releasing process of those 3, of course, because it's 100% for the last case. Okay, but
yeah, it's just the Holy Ghost. It's just a story, and a very incomplete story.
let's go back to the basic, everyday applications for this class. So you can think of the roller coaster. The roller coaster goes up. It's got more gravitational potential energy at the top because it climbed up.
No, it doesn't have anything, okay? And now you're going to let it fall. That is, you're going to let the force of gravity act on it without stopping it anymore. So you're just going to take the ground out from under it and now allow it to be moved by the force of gravity instead of transferring its energy. I'm right now, gravity's pounding me to pieces. And I'm pounding the earth to pieces. So if you take the earth away, I can't pound the pieces into the earth. I can't give them to the earth, and so then I'm stuck with them. So I have to move. But that's all you're really doing is just stopping the drain. You're stopping the energy from being drained out of me, and so now I'll move.
And maybe the motors and the things that that give this thing power, right? That power this thing, they did that work to get it up to this height. And then gravity takes over, and that gravitational potential energy is released into converted into kinetic
So
energy.
it's just mushy talk, okay? It's just, again, you don't talk this way about how a stream works. The stream obviously has to give its energy away. It can't keep it and move things. So when the Mississippi River moves the boat is consuming energy out of the river to be moved. Okay, it's more mass and velocity now going down the river. You've added mass and now you've diluted the velocity because you added mass. And that's still happening in these cases. So when something's free falling, it's actually, releasing. That's how it's best to describe it. It's actually collecting gravitational force that it eventually will deliver. So it's collecting it and then it's going to get delivered. But it's still the same force. The force would have just hit the train and gone right into the ground in little pieces when it's at the top. It's just going little pieces into the track, little pieces at a time. You let it fall, that means it's collecting the energy, it's collecting the momentum, it's collecting the velocity, and then it hits the ground, and all you did was change the time equation. You just said we're going to store it instead of allowing it to hit the ground, but when it hits the ground, it's going to be the same amount of energy over the same amount of time. It's just now you're going to impose the energy over a short period of time, and it's going to be capable of doing a lot more damage because the energy is moving faster.
As the coaster flies down the hill, it loses gravitational potential energy but gains kinetic energy. That's why it goes faster when it goes down the hill. Even if the motor stops doing anything, it doesn't need to do anything anymore because
It's just a key thing to understand that you can have the same amount of energy and you can put it over a small surface area and increase its potential to do damage, or you can impose it so quickly that it can't absorb it. So I can hit a glass with a little bit of energy at a very high velocity, the glass will break. Or I can hit it with a lot more energy very slowly and it'll resist breaking.
the gravitational potential energy is there. Okay. So I described a kind of complicated process there, but it made a lot of intuitive sense because we use this concept of energy. So that just shows you how powerful that is. You can even make sense of a roller coaster just right then and there without even needing to write out the equations.
So he says that makes sense. It doesn't make any sense at all. You're not converting potential into kinetic, and certainly you're converting it into momentum. That's all you're doing. And you've put the boat in the stream and you've let it go. You've cut the rope that's holding the boat and you're saying, go ahead, be pushed by the stream.
Explicitly. You just think about it in terms of like, okay, one form of energy converted into another, and then there
Again, Leonard Susskind teaches the subject of abstract Einsteinian relativity by using mock gravity, by using a physical mechanism to push objects.
you have it. So that's an example of how powerful this thinking is. Okay, what about spring potential energy? Well, I told you we can take a spring, take an object to it, and we can press the spring in. And the spring has a force, but it also has a potential energy that it can store. And then when I let go, that potential energy gets converted into kinetic energy because the ball.
No, it gets converted into momentum because there is no such thing as kinetic energy. It's a fable. It's a nonsense. An absolute fable. You don't have any evidence of it. Show me it collected somewhere. The ballistic pendulum can only collect 0.06% of the kinetic energy of a bullet. 0.06%. Why? Because it's a fable. That's why. Oh, jeez. It's just so irritating. You have to go over this and over this. It's such obvious nonsense. So the spring, the important thing is the spring relaxes. And it relaxes at a maximum. It only has a maximum speed. It can only expand so fast. It's pushing something. So when it's pushing something slowly, the energy goes in. And there's a point where the thing it's pushing leaves the spring. But the spring still has a little bit of push because it's going a little slower than the object, but it's still moving. So the object leaves and it's going a little faster than the spring. So the spring is going to pull out, but there's nothing to give its energy to. So, yeah, it has to wobble back and forth because it can't get rid of it. It reflects. And it just bounces back and forth in the spring. And that's showing you how much energy it didn't give to the object. So obviously the faster the object, the lighter the object you push with a spring, the less energy you get into the object, because the spring, when it leaves, when the object leaves, the spring is going to be going much faster with the lighter object, which means it's going to wobble a lot more because it's got a lot more energy still in it. That's real physics, never taught. I haven't heard a single physicist, a single lecture by Lewin or any of these guys, Stanford or Yale or any of the places that publish videos, ever talk about the fact that, yeah, the spring cheats because it gets a lot more energy into slow things than light things.
Gets moving, and at some point it stretches all the way out, and it's got nothing but potential energy again in the opposite direction. So it's got zero speed again when it's all the way stretched out, but now.
So again, it didn't have zero speed when the other object left. That's the point. The point is the object leaves before it has zero speed. It obviously can't push the thing going 10, 20, 30 miles an hour and then go 30, 25, 10 to zero and still be pushing this thing, because this thing left at 30. You can't catch up to it if you're only going 20, and you certainly can't catch up to it when you're going 10, and you're not going to catch up to it when you're going 5. So obviously, as the spring is slowing down, none of the slowing down energy, none of the decelerating energy goes into the object.
It's got another form of potential energy, and it pulls back and goes back and forth, back and forth.
So it's not another form of energy. It's only the energy it had, period. And it's just showing you the amount of energy that didn't get into the object. The spring kept it.
Forth. In a frictionless system, it just goes on forever. Of course, no system is actually frictionless, so you're going to have some losses as it goes back and forth.
I don't know if no system is frictionless. I mean, it's kind of a bold statement.
You'll see this in your labs that you do. So you'll do labs in this class, and you'll look at how the potential energy is released and converted.
I don't know exactly how they do labs online, but whatever.
Into kinetic energy and back and forth again by the spring system. Okay, then we've also got thermal energy. Thermal energy is associated with the motion of atoms that make up an object. It's really just the kinetic energy of it.
So thermal energy is just a real good illustration of this not ability to cancel. Energy can't cancel. So if you shove energy one way and you shove it another way, it's got to do this zigzag oscillating thing. No choice. And that's the motion, okay? The electrons and protons moving about. And when the electrons are pushing into the universe, they're pushing the force. And when they're pulling back, they're reducing, they're expanding the frequency of the energy. They're taking energy that was in a small amount of space and making it now over a wider amount of space. So they're constantly creating that infrared signature. And they're constantly doing it some positive degrees Kelvin. So that's the other key point, that it's really hard to get anything really, 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 really cold.
Atoms in disguise. And a hot object has more thermal energy than a cold object. Now, we're not doing thermodynamics.
So having thermal energy is, again, another, it's in a condition where it's trying to balance its atomic structure, but there's a whole bunch of noise in it still, and it's got to radiate that noise before it can settle down, and the magnets of the atoms, the polarity, can go back to their normal rigid state.
Dynamics in this class. Thermodynamics.
Colder state. And it's just a colder state. It's not a cold state, it's just colder.
Is 5b. But
I mean, hot and cold don't mean much in this context, except, infinitely hot means nothing, and zero, means nothing, because nothing's going to be in those two states. It's just going to be in some relative condition of amount of agitation. The universe is constantly agitating everything, and it's really hard to insulate anything from all of the energy.
Even without talking about thermodynamics, thermal energy is still a thing in this class, because when we have friction, like say we rub our hands together and produce friction, that heat that you feel.
So, and what are you feeling? Again, is it the conflict that you're creating, the energy, causing oscillations? But what's really happening is you're giving away energy. You have contact with some other mechanism, then the two things are going to say, what's your temperature? Let's share our temperature. Let's share our condition. And that's what they're doing. And so if one is moving and one's not moving, well, they're going to share the condition. So that's what contact provides the opportunity for. Obviously, when things stick together, they have lots of time to share their condition. When objects are elastic, then there's an obstacle to them being in contact long enough for their conditions to be shared. And it's so much easier to share conditions when things are exactly the same. So if, the Newton's cradle, you're just saying, I'm going to be introducing a force, and I've got something that can take exactly the condition I'm in, it can be put in. So I can just directly put the money in its bank account. I don't have to convert it into, American dollars versus Canadian dollars or some sort of crap. I don't have to do any conversion because the object can take all the energy as quickly as you can deliver it. Other objects can't take the energy that quickly because they have to convert it into a higher velocity or a lower velocity.
That's thermal energy. That friction produces heat. So we do talk about friction and objects rubbing together and producing friction. So we're still going to have to do thermal energy sometimes, even though we're not doing things with heat engines and things like that. Thermal energy is still a thing in this class too. And
well, the idea that at least he's called it thermal energy and recognized that it's not any different than work or anything else. It's motion. That's all that counts in the universe. That's energy, motion. Something moving is energy. And the argument is that the simple point I'm making is the only thing that's really moving is the force bits, and the matter bits are pushed around by it.
That's where it comes.
By collecting it, by it sticking to them. They can't collect it if it doesn't stick to them. Okay, they have to use its energy to move. They have to possess it to move. They can't move if they don't have the thing going that way. The thing going that way has to stick to them, and then they can go that way.
Comes in for this class. It's the kinetic energy. Well, not kinetic energy. It's the energy associated with friction, I should say, of the rubbing together. Yeah.
So friction is just a transfer. And in most cases, it's going to be used to transfer energy out, steal something's energy. Obviously, you can use friction when you're accelerating your tires fast and you want to go. Well, yes, the more the friction, the more efficiently you can make your tire move. Because you're, again, just transferring the differential.
Okay. So chemical energy, that's kind of what I was talking about with actually, it's exactly what I was talking about when I talked about how you can have an electron and a proton and changing the distances and the bonds associated with the electrons and protons and how those things are.
Well, obviously this is more complicated than just that because this is the chemistry. This is the actual atoms separating and creating different compounds. So you're converting atoms that are in some hydrocarbon arrangement, and you're going to break it into carbon dioxide and some other thing and some other thing. And you're basically breaking atoms that were stuck together, and breaking them means there's pieces that fly off. The little pieces are let loose, going the speed of light.
Related. That's chemistry right there, and that's chemical energy. It's associated with molecular bonds. And it's a locality thing, so the locality of the electron matters and determines how much energy the system has. And as atoms are rearranged during a chemical reaction, this energy can be absorbed or released. It can be absorbed to produce a higher energy configuration where we put heat in the heat, or not just necessarily the heat, but whatever form of energy we put in, it goes into the system and it gets absorbed, and now it has a new location and a new bond. And that takes energy.
So you could almost argue it's not like I could take an Earth with all that molten crap and I could break it into pieces, and the pieces would create a crust and a crust and a crust, So in the process, I would lose some of the heat. That I had a more efficient heat storage when it was one object. I have less efficient heat storage when I break it into pieces.
To do that, okay? Or we can do something and it releases energy in the process. That's typically a burning process, like when we burn gas, that releases energy. So
yeah, it's all about small things, being broken into, big things being broken into small things, releasing extra bits. And the pressure argument is that you're taking stuff under higher pressure and making it under lower pressure. Expansion is a reduction in the pressure. compression is an increase in the pressure, and that's the storage part. So you can gain a lot by expanding something.
There's endothermic and exothermic reactions, like you remember from chemistry. That's exactly what we're talking about here. Okay. Endothermic is the heat absorbing, exothermic is the heat releasing. So the energy principle, system of environment, when working with energy, we need to be able to distinguish clearly between the system, the objects whose motion and interactions we want to analyze, and the environment, which is
So you don't need to do any of that more than just realize that obviously if the environment has some previous condition, and is the condition stable? So I can do an experiment, even though a bunch of gravity is coming down, we can do an experiment as long as we understand what gravity is taking out of the experiment. So you can do it in air, and you can know the air resistance has got a real effect. So it's not like you can't do the experiment unless you isolate a system. You just have to understand what's influencing the system. And those other influences are just as real as the ones you're measuring, for example. So why wouldn't you measure them? So why wouldn't you stick a thermometer in the ballistic pendulum? If you're going to say there's 1999 joules of energy stuck inside of the ballistic pendulum, well, stick a thermometer in there and show me. But they don't do that.
the objects external to the system that exert forces on an object inside the system. So here we have a little diagram of the heat and the work that goes into the system, and then the system has some system energy, so E subscript system.
So, I mean, obviously heat is work, heat's energy, so it's just silly not to call heat what it is. It's energy, it's more energy. The higher the temperature, the higher the energy. So heat is energy.
And then it can be transformed back into heat or work. And its energy added has to...
So it really doesn't mean anything, right? He's just basically saying heat equals heat. That's the thermodynamic part. The work is just arbitrary. That's just us saying what part of it do we like. I like the photons that hit me. They're the work part. They're doing work on me. But they're doing work on all over the frickin' room, okay? They're doing work on him, okay? There's work all being done by the photons all over the place. So it's just silly to make this distinction between, okay, the work I'm going to count and the work I'm not going to count. It's all the same work. It's all just heat in, heat out. And it has to be refueled. And that's the joke of bent space, is it breaks the refueling. You can't believe in bent space if you believe in conservation of energy, because you can't convert heat into bent space.
To equal energy removed. So what this is kind of a, not a super descriptive figure, it's just a start, but what this is going to turn into is it's going to turn into energy conservation equations.
Yeah, and the equations won't have any reasonableness because there won't be any real conservation, because you're never obeying the rule, which is momentum is controlling all this, not kinetic energy. It's a momentum engine. It's just masses and velocities. That's all that's in the universe, masses and velocity. The bits of the photon have a mass, the electrons and protons have a mass, and that's all there really is. There's just bits of force and bits of matter, and the fact is that you have to always have the same amount of mv moving in the universe at all times.
That's what this pictorial slide is going to turn into eventually. And here we go. So if you look at the bottom left corner, you see that the E system is equal to the kinetic energy plus...
So the arbitrarily fake made up bullshit energy. He could just easily just say the momentum. There's no, it wouldn't break the formula in any significant way at all to just say momentum is the quantity of motion. And we're all the way back to Newton's quantity of motion. It's a quantity of motion.
The potential energy plus the thermal energy.
So there's no such thing as the potential energy, because that's just circumstantial. So you're going to contact a certain part of the water in the Mississippi River and extract energy from that portion of the river. That's all you're going to do. That's calculable.
Energy plus the chemical energy plus any other types of...
So it's just silly to start talking about the nuclear and the chemical, because that's really circumstantial and has nothing to do with any individual bit of energy. So I don't even know why he's going there, because it's pointless. You can't quantify that energy that simply.
Energy that we have. So we say that the total sum of the system, E system, is the sum of all of those energy terms. And then there's a final and an initial, and the final has to equal the initial.
Right, so he's just saying there's conservation, but there's no conservation mechanically. So he can't show you the mechanical systems where this conservation takes place. So, it's just a made up statement. This equals this, but I never prove it.
So, and we haven't gotten to that yet, but that's where we're going. For now, just note that we have to sum all of the forms of energy that we're talking about in a given problem, and that's the total energy that
The only parts that are going to matter are the parts that are actually going to be actively converted. The only parts you could see are the parts that are converted. The parts that are inside of something and they don't change, why would I count those? Wouldn't be any point. I mean, if the brick is still going to be a brick after the experiment, I don't have to worry about the atoms of the brick.
the system at some initial point. Within a system, these types of energy can be converted into one another without loss.
So there's no kinds of energy, there's just kinds of object. So it can be an elephant, or it could be a mouse, or it could be, a DNA molecule. Doesn't It's always just in a form that's either easy to see or not easy to see. It's motion. It's either in soft or hard objects. If I put weight on a bridge, the bridge is physically stressed by the weight, and we can't see it, but we can measure it by making a plastic bridge and seeing the change in the molecular structure because it reflects light differently because it's under stress.
So we have conservation of energy. So kinetic energy can be converted into thermal energy. And as long as the system doesn't interact with its environment, the system energy remains constant. So we have an isolated system of two objects, and they're exchanging energy with each other.
So again, the idea of an isolated system just in our real world is kind of silly. We really can't isolate ourselves from gravity. We can't isolate ourselves from air pressure. All of these things are really hard to isolate yourself from. So there's no real point in it, but whatever.
that energy will be conserved as long as we don't bring something else in and give one of the other objects energy from somewhere else. Then energy conservation does not occur because we have another additional system coming in. But as long as we just have
It still exists as long as you account for the extra thing coming in. So there's always conservation. You just add in a new input. So it doesn't matter. It doesn't have to be a closed system as long as you're agreeing that you're going to observe all of the influences, all of the variables. So as long as you're saying I'm going to pay attention, it's not a problem.
these two systems, this total system, I should say, of these two objects, and we don't look at anything else, then energy is conserved. And it isn't necessarily two objects. It could be like, a whole giant collection of molecules or atoms. It could be billions or trillions of them. But the point is that we just look at those objects exchanging energy, and we don't look at anything else. For example, if you look at, a gas in a container, it could be trillions of gas molecules, and they're all bouncing up against each other, and they're changing velocities, right? They're exchanging energy. But the total temperature of the gas, if it's isolated and isn't interacting with the environment, let's say it's thermally isolated, it's in a special container where it doesn't gain energy or lose energy from the environment, well, then the total energy of all of those gas molecules is going to remain constant.
Right. So the point to make is that's exactly the universe we exist in. So that's exactly how it works. Sometimes things are going fast, sometimes things are going slower, and it all evens out. There's a certain number of heads and then a certain number of tails, and it's all going to work out to be even in the end. There can be places that look like there's a lot of stuff going on and, lots of energy, but there'll be a dissipation eventually, and it all, recycles back into the system. Suns are born, suns get old, and suns blow up. Anyway. All right, well, we're over an hour, so I guess I'll stop there. I mean, I'm sort of saying, well, why not just really beat the hell out of this subject? But I think I've already beaten the hell out of it. So we'll see if we get any reply. But, I mean, this is junk physics. They shouldn't be teaching this garbage. It's all based on, again, you go through the history. If these physicists would just read the history, just read how bad the evidence really was. Okay, so it starts with Huygens just writes v squared in his notes in some lecture. 20 years later, Leibniz digs it up and starts saying it's a whole theory, okay, of living force, vis viva. Then we have to wait all the way until the 1720s. Obviously, Leibniz was buried a nobody, and nobody liked him, and nobody went to his funeral. He didn't win the argument, quite obviously. You didn't get Newton thrown in jail. And then de Chardolay, this woman who wasn't a real physicist. I mean, she was tutored by a Leibnizian, okay, which is just kind of funny. Um, and she does these denting clay experiments, denting clay with round surfaces. And the physicists of the time couldn't figure out that's not logically sound. Okay, you can't dent the clay. You have to penetrate the clay. If you just dent it, then you're cheating, because the side with less energy is going to have to hit more flat surface, and the side with more energy is going to be pushing more sideways. So the one side has to do more work than the other side. So it's not a fair fight. And then she does other experiments where she just counts how far something is flown. So she hits something with a high velocity, the little pieces fly further. So she says it has more energy because the pieces flew further. I mean, the logic is garbage. And then they had a contest in France, and nobody entered it. And the 3 papers that were entered were all convoluted thought experiments that didn't say a damn thing. So the whole argument was never happened. And then in the 1850s, they just made up this crap of the work equation and decided to immortalize this mv squared thing that they've never proven. They don't have a single experiment demonstrating it to be the truth. 4 pounds dropped 1 foot is not the same impact energy as 1 pound dropped 4 feet. It's not. It doesn't work. It's only 2 units of gravity. Yeah, okay, so that's enough. Anyway. So till the next time and such. But I mean, look, they're teaching this stuff, so it really is. It's fair, it's fair to be critical because they're teaching it. If you're going to teach it, you better know what the fuck you're talking about. You better be able to defend it. And I don't think any of you physicists can defend any of this crap, and that's why I haven't gotten a single reasonable response from a single physicist in 2 frickin' years. They won't answer any of the 45 direct points I've made just in this video. In this video, I've made a ton of points, and they're not going to respond to any of them. All right. So, till the next time and such. So, we just have a record of it. So, I'm just saying, see, you try to talk to these people, you try to counter their physics, and they wouldn't have it. They wouldn't let that argument take place because they don't have any evidence. The fact is, the lunar module was landed on the moon using momentum. Because momentum gets right answers, and kinetic energy gets wrong answers. Fact.